Step outside tonight. Look up. If it's clear where you are, you'll see it, or the memory of it. The light the sun left behind before it dipped below the horizon. That warm, familiar glow that has followed humanity through every single moment of its existence. Every war, every harvest, every child born squinting into the world. You've never known a day without it. Neither did your parents. Neither did the people who built the pyramids, who painted caves in France 30,000 years ago, who looked up at the same star from the same small planet and probably never once considered that it might end. We don't think about it either. Why would we? The sun rises. The sun sets. It is the one thing that has never failed. But here is what nobody tells you when you are learning to name the planets in order. Mercury, Venus, Earth, and Mars. What nobody puts on the poster in the classroom next to the cheerful yellow circle at the center. The sun is not stable. It is not sitting still. It is not waiting. It is burning through itself, second by second, in an act of controlled violence so enormous that the human mind was simply not built to hold it. Every single second, the sun converts 600 million tons of hydrogen into helium. 600 million tons every second. It has been doing this for 4.5 billion years. It will do it for approximately 5 billion more. And then something will happen that will make everything you have ever known, every city, every ocean, every mountain range, every fossil record of every creature that ever walked this planet, completely and permanently disappear. Not metaphorically, physically gone, and the earth itself swallowed. And here is the part that should stop you cold. The process that ends everything did not start at some distant future moment we can safely ignore. It started before your grandparents were born, before Rome, before the first human stood upright on the African savanna and looked at the horizon. The sun has already begun to change. It is happening right now as you read this, as that light falls on your skin and feels like warmth and safety and ordinary Tuesday afternoon. The star is aging. It has been aging since before we arrived. We just never noticed because we are not built for geological time. We are built for seasons, for decades, for the span of a single human life, which is to the life of a star what the blink of a camera flash is to the entire history of cinema. We blink. The universe doesn't notice, but there is something strange and almost unbearable about standing here, in the middle of the star's life, close enough to benefit from its light, and knowing, now, today, with the science we have, exactly what is coming, exactly what it will look like, exactly what will happen to this planet and everything on it. We are not guessing. We are not extrapolating wildly. We have watched other stars do this. We have the physics. We have the models. We have looked at stars in their final stages, billions of light years away, and we have said, that is us, eventually. This is not a horror story. It is something stranger than horror. It is the biography of the thing that made you possible, written in light and heat and the slow, patient consumption of its own fuel. And it ends the same way all biographies end, with silence. Stay with this, because before we get to the ending, we need to understand what the sun actually is, what it is actually doing, and why the changes already in motion will reshape this planet long before the final act. The ending is 5 billion years away. The consequences are not. Let's start with what the sun actually is, not the poster version, not the symbol, but the physical object. The sun is a sphere of plasma approximately 1.4 million kilometers in diameter. If you replace the Earth with the Sun, the Moon would still be inside it. The Moon, which takes 3 days to reach by spacecraft, would orbit inside the Sun. Every single one of the nearly 8 billion people on this planet, every building, every ocean, every mountain, all of it would exist within the interior of a single star. That is the object we are talking about. And at its core, buried under 700,000 kilometers of crushing plasma, the temperature is approximately 15 million degrees Celsius. Not at the surface, at the core. The surface is only about 5,500 degrees. The core is where the work happens. The core is where hydrogen atoms are forced together under pressures so extreme that they fuse. And in fusing, they release energy. That energy is what you feel on your face on a summer afternoon. It took that energy approximately 100,000 years to travel from the core to the surface. 100,000 years. The warmth you feel right now left the center of the Sun when humans were still in the Stone Age. That is the first thing you need to understand about the Sun. It operates on timescales that make human history look like a rounding error. Now, here is where the aging begins. The Sun's fuel is hydrogen. It has a finite amount of it, and for 4.5 billion years, it has been steadily converting that hydrogen into helium in its core. Helium does not fuse at the same temperatures hydrogen does, so as the core accumulates helium, inert, non-fusing helium, the fusion reactions migrate outward into a shell surrounding the increasingly dense helium core. This is already happening, right now. As the fusion shell expands outward, it generates more energy. More energy means the outer layers of the Sun, the ones we see, are pushed further out. The Sun is slowly, almost imperceptibly, growing. Over the past billion years, it has become approximately 10% more luminous. In another billion years, it will be hot enough that the Earth's oceans will begin to evaporate. Not flood, not freeze, evaporate. The water cycle will collapse. The planet will lose its liquid water to space. Hydrogen stripped away by the solar wind, oxygen left behind. The surface of the Earth becoming something between a desert and a furnace. Life, as it currently exists, does not survive this. Not because of a catastrophic event, because the star at the center of our solar system did exactly what physics required it to do. We are not in the path of an accident. We are in the path of a process. But that, 1 billion years from now, is only the first act of the ending. The Sun, as it is currently classified, is a G-type main sequence star. Main sequence means it is in the stable middle phase of its life, fusing hydrogen to helium in a balance between the outward pressure of fusion energy and the inward pull of gravity. This balance is what makes the Sun so reliable, so constant, so easy to forget about. The main sequence ends when the hydrogen in the core runs out entirely. That happens in approximately 5 billion years. When it does, the Sun will have no fuel left to sustain the pressure against gravity at its core. Gravity wins. The core collapses inward, compressing into a ball of helium that grows denser and hotter, hot enough to begin fusing helium itself. The energy released from this collapse and from helium fusion is colossal, catastrophic in scale. The outer layers of the Sun respond by expanding, not a little. The Sun will swell into what astronomers call a red giant. It will expand to somewhere between 100 and 200 times its current size. In this phase, it will consume Mercury. It will consume Venus. And the current best models, not speculation, but models based on direct observations of other red giant systems, suggest it will reach approximately the orbit of Earth. Whether it swallows the Earth entirely or leaves a scorched, airless rock orbiting through the star's outer atmosphere depends on variables we cannot yet precisely calculate. Either way, there is nothing living here to witness it. Because long before the sun expands to consume the inner solar system, it will have become too luminous to sustain life on Earth. Too hot, too bright. The surface temperatures will be incompatible with liquid water, with photosynthesis, with chemistry organized enough to be called alive. But here is the gut punch fact, the one that puts all the 5 billion year numbers into a frame you can actually feel. The sun, right now, is more than halfway through its hydrogen. Halfway. We are not at the beginning of this story. We are past the middle. The sun has already burned through more hydrogen than it has left. The clock is not starting. It is running. It has been running since before this planet had continents. Since before the first single-celled organism figured out how to replicate itself in the shallow seas of an early Earth. We arrived late to a story already in progress. And the question that should now be pressing itself against the inside of your skull is this: if the sun is already past its midpoint, if the changes are already in motion, then what are we exactly in the context of this timeline? How do you locate yourself in 5 billion years? How do you locate your entire species? What does it mean to be alive in the middle of a star's biography? Here is something true. Every atom of calcium in your bones was forged in the core of a star that died before the sun existed. Every atom of iron in your blood was scattered across space by a supernova, an explosion so vast it briefly outshone an entire galaxy. And that scattered material eventually collapsed into the disk of gas and dust that became our solar system, our planet, and eventually you. You are not a passenger in the universe. You are made of it. The sun that is dying was also, once, a different kind of dying, the remnants of older stars, compressed by gravity, ignited into a new cycle. Stars don't just end. They seed the next generation. The carbon in your cells, the oxygen in your lungs, the silicon in the sand, none of it came from nowhere. It came from deaths that happened before our sun was born, in a chain of creation and destruction that stretches back to the first 3 minutes after the beginning of everything. We are, quite literally, how the universe has come to know itself. That is not poetry. That is physics, and it matters. It matters in a way that should reshape how you feel standing on this planet, because it means that the ending of the sun is not the ending of the story. Red giants collapse. They shed their outer layers into space in what astronomers call a planetary nebula, a shell of glowing gas expanding outward at thousands of kilometers per second, lit from within by the exposed core of the dying star. That core, dense and white-hot, is called a white dwarf. The sun will become one. It will be roughly the size of the Earth. It will weigh most of what the sun currently weighs. It will cool slowly over billions of years, radiating the last of its heat into the darkness, dimming from white to yellow to orange to the deep, invisible cold of a black dwarf. No star in the observable universe has existed long enough to become a black dwarf yet. The universe is not old enough. This fact should stop you in place for a moment. The universe is 13.8 billion years old. The sun is 4.5 billion. It will become a white dwarf in another 5 billion, and even then, it will take hundreds of billions of years to cool to nothing. The universe we live in is still in its very early morning. The overwhelming majority of the stars that will ever exist have not been born yet. The era of stellar formation is only beginning. We are not at the end of anything. We are at an almost comically early moment in cosmic time on a small, warm rock around a middle-aged star in one arm of one galaxy among 2 trillion. And somehow, through a chain of events so improbable that some cosmologists use the word miraculous and mean it technically, we are conscious. We are aware. We can calculate the fate of our own sun, trace it forward 5 billion years, and feel something about what we find. No other known object in the universe can do that. The rocks cannot. The gas clouds cannot. The white dwarfs cooling in the dark cannot. Only us. And perhaps that is the real weight of all of this. Not the 5 billion years. Not the planetary nebula. Not the swallowed Earth. The weight is this. We exist in a window. A specific, finite, unrepeatable window of time in which this planet is the right temperature. The sun is the right brightness. The conditions are improbably aligned in all the ways necessary for something like awareness to exist. That window closes. Not today. Not in 1,000 years. Not in 10,000. But it closes. Physics requires it. The question is what you do inside the window. The sun will not remember us. The universe will not record our passing in any language we can read. In 5 billion years, when the outer layers of this star drift outward as a planetary nebula, beautiful, slow, utterly indifferent, there will be no trace that we were here. No monument that survives stellar temperatures. No archive that outlasts evaporation. What we have is now. This light. This ordinary, unremarkable, terrifying, irreplaceable light. 4.5 billion years old, traveling 8 minutes across empty space to land on your skin without asking anything of you, without knowing you exist. The sun is dying. It started before we arrived. We got here just in time to notice.